You know, we're surrounded by AI all the time, but do we really have any idea what's going on inside its head? Today, we're going to get into this huge question at the very heart of artificial intelligence, this constant battle between being able to understand why an AI makes a decision and just making it as powerful as it can possibly be.
Okay, let's just jump right in with something that'll really get you thinking. Picture this, you're riding in a self-driving car, and all of a sudden it just starts making these weird, random turns. And when you ask it, hey, why'd you do that? The car just says, because my calculations told me to. Yeah, not exactly reassuring, right? That scenario, that feeling, gets right to the core of what we're talking about today.
And that feeling, right, that need for a better answer, it all comes down to trust. I mean, before we can really hand over the keys to critical tasks, we have to be able to trust the AI's judgment. And that trust, well, it's built on two really big ideas: transparency and explainability.
So first up, we've got transparency. The easiest way to think about this is like a GPS that shows you the entire route it's planned, turn by turn. A transparent AI model lets you see the whole process, all the gears turning, all the logic it's using, from the very start to the final result. You get to see how it's thinking, every single step of the way. Now, explainability? That's a bit different. It's less about seeing the whole journey and more about just understanding one specific stop. So let's say an AI denies your loan application. Explainability is its ability to give you a clear, simple reason why. Something like, the loan was denied because of a low credit score. You get the reason, even if the system that came up with it is, insanely complicated. Okay, so this whole idea, this difference between seeing the how and understanding the why, it basically splits AI design into two big camps. On one side, you have what we call glass box models, and on the other, the kind you always hear about, the black box. And this chart, it pretty much says it all. Glass box models are built from the very beginning to be see-through and easy for us to understand. Black box models? Well, they're the opposite. They're often so complex that figuring out their logic is next to impossible, even when they're getting incredible results.
So what's a glass box actually look like? Well, a decision tree is the classic example. It's literally just a flowchart. You can follow the path from the top, answering each question, and see exactly how it got to its final answer. It's straightforward, it's clear, you can interpret the whole thing.
And then you've got the black box. The perfect example here is a neural network, which is kind of modeled after our own brains. It's this massive, tangled web of connections. And yeah, it can spot patterns in data that no human ever could, but trying to trace a single decision back through that web, it's practically impossible. It's unbelievably powerful, but what's going on inside is a total mystery.
And right here, this is where we get to the real heart of the problem. This isn't just a simple design choice, it's a fundamental trade-off. You're basically choosing between clarity and raw power.
Just look at this chart. It lays out the dilemma perfectly. That simple decision tree, super easy to interpret, it gets a high score there, but its accuracy often isn't the best. And the complex neural network, it's the complete opposite. Its accuracy can be absolutely amazing, but good luck trying to figure out how it works. You almost always have to sacrifice one to get more of the other.
So you might be asking, why? Why can't we have both? Well, a line from the research really nails it. It says that the very same complexity that lets a neural network find all these amazing hidden patterns, well, that's the exact same thing that makes it a black box, the thing that makes it so hard for us to wrap our heads around. But wait, it gets even trickier. This isn't just about performance versus clarity. Once you start thinking about how this stuff works in the real world, you slam right into another even more complicated issue, the safety dilemma. So look, on the one hand, transparency feels like a no-brainer for safety, right? It lets us peek inside and find problems like hidden biases or weird, harmful behaviors we didn't expect. But, and this is a big but, there's also such a thing as too much transparency. If you lay out the entire blueprint for how your system works, you might also be pointing a giant neon sign at its weaknesses, which you can bet someone with bad intentions will try to exploit.
So you see, this isn't just some abstract problem for computer scientists to figure out in a lab somewhere. This constant tug-of-war between clarity, performance, and safety, it forces us to make some really tough choices about what kind of AI we actually want to build and let into our lives.
So it's a balancing act, right? On one side, you have these simple, clear models that we can trust because we can understand them. On the other, these incredibly powerful, complex models that get amazing results. And we've seen how even trying to be fully transparent can backfire. Which brings us to the final and most important question. When it comes to a self-driving car, or a tool that helps doctors diagnose diseases, or an AI that decides who gets a loan, what do we prioritize? Do we go for the best possible performance, even if we can't fully explain it? Or do we demand transparency, even if it means the results aren't quite as good? What price are we willing to pay?